Okay, Assalamualaikum and good afternoon. My name is Muhammad Ahmad Izzuddin bin Muhammad Zaidi, number matric 1021. Today, we are going to explain about greenhouse climate control. Okay, next step. It's like this. Okay, for introduction about greenhouse. Greenhouse is a structure designed to protect crop and provide a controlled environment for optimal growth. And inside the greenhouse, temperature, humidity, and light intensity must be kept within suitable range. And the third, manual climate control can be inconsistent and labor intensive. And last, automation using PLC, programmable logic control, allow precise, continuous, and efficient control of environmental conditions. Okay. Now we are going to PLC. What is PLC? PLC is a digital control device that automates mechanical and electrical system. It reaches signal from sensor, process the data and control actuators such as fan or heater. PLC is operated in real time, ensuring quick response to any change in greenhouse condition. In agriculture, PLC are widely used for irrigation system, fertigation unit, and the last, greenhouse climate management. So, that's all for me. Now, I will pass to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadif and my last metric number is 1018. Now, I will explain about the main components in a greenhouse PLC system. First component is temperature sensor. The function is it measures a temperature inside the greenhouse. So, the sensor like thermocouple or RTD continuously monitors the air temperature and sends an electrical signal to the PLC. The signal strength changes with the temperature, allowing the PLC to determine if the greenhouse is too hot or too cold. Next is humidity sensor. It monitors moisture levels in the air. This sensor, often a capacitive or resistive types, detects the relative humidity of the air. When the air becomes too dry or too moist, the sensor sends this data to the PLC so it can activate or deactivate the misting system. Next is light sensor LDR. It detects sunlight intensity to adjust artificial lighting. The light dependent resistor LDR changes its resistance based on the brightness of sunlight. The PLC reads this change and decide whether to turn on or off artificial lights, ensuring plants get optimal light levels for photosynthesis. Next is fan or ventilation system. It reduces temperature and increases air circulation. Okay. When the PLC detects high temperature or humidity, it turns on the fan to draw in the fresh air and remove hot air. This keeps the greenhouse environment stable and prevent plant stress. Next is heater. It raises temperature when it's too cold. During cold condition, the PLC sends a signal to activate the heater to warm up the greenhouse until the desired temperature is reached. Next is misting or fogging system. It increases humidity and cools the air. The misting nozzles release fine water droplets to raise humidity and slightly lower temperature. The PLC activates it when humidity level fall below the set threshold. And lastly is PLC controller. The function is central unit that process data and send output signal to control device. The PLC receives all sensor All sensor data, process it using the program logic like ladder diagram or structure text, and send signal to control device like fan, heater or misting. It's like the brain of the system. Next topic is how PLC process input and output.
Step-by-step operation cycle. The first one is input stage. The first one is sensor like temperature, humidity or light. Send analog or digital signal to the PLC input module. And each sensor provides data representing the certain greenhouse condition. Second is processing stage. The PLC CPU reads and compares the input data to present desired values. And based on logic programming, the PLC decides what action to take. Next is output stage. The PLC sends control signals to output device like turn on fans if temperature is too high. Second is activate misting system if humidity is low. And lastly, it switch on heater if temperature is too low. And once the environment returns to the target range, the PLC automatically deactivate the device. And lastly is cycle continuity. This input process output cycle repeats continuously, allowing real-time automatic control of the greenhouse environment. And that's all from me. Now I will let my friends to continue our presentation.
Good afternoon to the audience. Today, I would like to proceed with our presentation. Before I continue, I would like to introduce myself. My name is Muhammad Rafiras Mekabindaus, metric numbers 1039. We will write the advantages of using PLCs. Okay, so the first point is accurate and consistent control. Maintain stable temperature, humidity, and lighting quality control. So the system will offer many benefits, especially in agricultural terms. Second, energy and water efficiency. With PLC, we can save as much as a lot of water and energy, because if we use too much air, there will be waste. The third one is reduce labors. With PLC, we can minimize the labors of work, so that people can rely on robot more than do physical work. Then the fourth one, flexibility. PLC can do various work, even if the work can be done by human, but then the PLC we can easily do it. Then high reliability. Can run continuously with minimal maintenance. So PLC robot, PLC system can do a lot of work without routine checkup. What I mean is the machine will last longer and require minimized maintenance. And last but not least, data logging and monitoring. Can record environmental data and connect with IoT for remote supervision. With this, PLC always preserve data to be used into the future. Next slide, please. Okay, so we will proceed to the limitation of using PLCs. First one, as we know, PLC system is very, very expensive. So we need a lot of money to install and set up for small farms. Second, require technical knowledge. PLC system require a certain knowledge, because if we don't learn how to use PLC, then the PLC system will not working efficiently. The third one, dependence on power supplies. PLC system require a lot amount of electrical power. So we need a high or an expensive generator that can generate limited scalability. Complex expansion may require upgrading hardware or software. That means that the existing system needs to be updated regularly so that the system will not be updated and can perform more work in the future. That's all from me. Thank you. Next, I would like to invite my friend.
Assalamualaikum, my name is Razik and my magic number is 1001 and I am the last member of this group and I'm going to present the last part of this slide. Conclusion: PLCs play an important role in modern agriculture automation. In greenhouse, control PLCs maintain the optimal growing environment through precise measurement of temperature, humidity and light. Third point is, despite the initial cost and technical requirements, PLC systems greatly improve efficiency, productivity, and sustainability in crop production. And last point is, this technology supports the concept of smart farming. Most important, where automation and data-driven control